we were focusing on the basic operations of BGP as well as the configuration of BGP, in which we have learned the reason why we need to use update source. By default, egress interface means the exit interface address becomes the source address. We saw that the source address of the BGP packet will be compared by the receiver to its neighbor statements. Only if the match found, the relationship is going to be established. If not, no neighborship. It will go to idle state. Again, after some time, it will try going to active state. Again, it will come back to idle state. So we have to make sure the source address and the neighbor address that is mentioned in the neighbor router's neighbor statement matches. Most of the time, whenever we have multiple paths to reach a neighbor, we need to know what you learned in the previous slide. Why? Because whenever we have redundant path, we make use of loopback interface address to peer. So we have to source it from our loopback so that the source address of my packet will match with the remote router's neighbor statement. For example, when I try forming neighbor between A and D using the loopback interface IP address 1.1.1.1 and 4.4.4.4, on router A, I'll source with loopback 0 so that router D's neighbor statement, which is 1.1.1.1, will match. So here is an example. We are forming neighbor between B and C using loopback interface address. So we have to say update source loopback 0. And if there is any genuine reason for you to use any physical interface instead of loopback, you can do so. But we always recommend to use loopback interface. Reason number one, loopback interface will be available as long as the router is available. But the physical interface cannot guarantee. Physical interface may go down even when the router is available. So when I form using physical interface, when the interface goes down, I lose my neighborship. So highly recommended is to use loopback interface. So your update source will also be loopback interface. There are many other reasons why I should use loopback interface. I would like to give you another important reason why I should use loopback interface only to form IBGP neighbor when I have redundant path. Usually, if you see ISP topologies or full mesh topologies, ISP is a mesh topology, meaning there are redundant paths between the provider edge router. In our example here, router B and C are considered to be a provider edge router. So between the provider edge routers within the same autonomous system, we form MPBGP tunnel. We call it as layer 3 VPN. When you use layer 3 VPN, there are three protocols involved in providing you layer 3 VPN. Number one, the OSPF. 2 MPLS LDP, 3 BGP. Now, all these three protocol needs to sync each other to provide you a layer 3 tunnel, for which they need to have one common router ID. For me, this is the most important reason why I should use only loopback interface to form neighbor. Because MPLS, OSPF and BGP will use the loopback interface as the router ID. When all three uses the same router ID, they both can work together and provide a layer 3 VPN. If not, your control plane will be good, but the data plane will be broken. You'll understand the depth of what I said when you come to MPLS layer 3 VPN topic. My intention is not to teach those things now. I was just trying to make you visualize that there is something big works in network depending on the router ID. And it is important for us to use only the loopback interface in order to form IBGP neighbor. That's my intention of telling that story, the big MPLS story. So we had to use loopback interface to form IBGP neighbor. Whenever you form neighbor using loopback interface, without fail, we have to source it with that loopback interface, which we use it as a peer address. Even if you have multiple loopback interface, you need to be very precise in configuring the update source interface. We should not give wrong loopback interface. Between EBGP, between EBGP there are less reason why I should use loopback to form neighbor. In case if you have a need to form EBGP using loopback, then we have to increment the TTL value by using this command. Neighbor IP address, EBGP multi-hop, and whatever the number that you mention here is going to become the time to leave value of the BGP packet. Time to leave for what? Incoming or outgoing? It is not for incoming, it is for outgoing. So we tune the outgoing TTL value by using this command EBGP multi-hop. The default TTL value is only 1. As a result, the neighbor address that you configure needs to be seen in the routing table as directly connected. This design is for the security. But when I am forming neighbor using loopback, the loopback interface address, for example here, in router A's routing table, 1.1.1.1, which is loopback 0 of router B, which is loopback 0 of router B, cannot be seen as directly connected. It cannot be. So what I have to do is I need to break the rule of directly connected. EBGP need to be directly connected. That rule need to be overridden by typing this command EBGP multi-hop 2. Only after you put this command, packets will be generated and shared. If you fail to give this, if you fail to give this, the packet even won't go out. because the default TTL is 1. And default TTL is 1, the neighbor 1.1.1.1 is not going to be seen in the routing table as directly connected. It is not directly connected, it's behind R1, RP. So we have to increase the TTL value. Why do we need to write this static route? On router A, we are saying in order to reach this 111 network, you can go to 1.18 as well as 1.34. We are providing reachability between the loopbacks so that BGP can do three-way handshake and do the other necessary negotiations. So for BGP, IP path is important. IP path is important. We need to write a route. Secondly, we have to source it with the right interface IP address. So we say update source command. Thirdly, we have to increase the TTL value so that the default constraint can be overridden. So these things we have seen. Also, we saw the next stop behavior. Router C will find 10, 10, 10, 3 as the next hop in order to reach 172.16.00. That is the next stop behavior. Router B will not assign its address. Router B will simply carry the eBGP address as the next hop while it advertises 172.16.00 to router C. We also learned another next stop behavior, this one. That 172.30.00 network, 172.30.00, A will find next stop is 10, 10, 10, 2. But actual neighbor for A is 10, 10, 10, 1. A is configured to form neighbor with B, even though it is forming neighbor with B. To avoid unnecessary hops, C will advertise 10, 10, 10, 2 as the next hop as it advertises to router A. B will advertise the C's address 10, 10, 10, 2 as the next hop to router A. And also we learned that because of the next hop behavior, the internal router, this router has got no reachability to this IP address. So we need to say next hop self here. We need to go to router B and say neighbor IP address of router C, next hop self. When you do that, router A will receive with the next hop 10, 20, 10, so 172.20, 10, 1, which is reachable from C. As a result, C can use the given BGP given route. Next. If I have multiple routers, let's say I have another router here, another router here. Even in this router, when you learn 172.16.0.0 network, the next hop will be this router's address because you said next hop self here. It won't be address of C router or a D router. Let's say this is D router. We no need to say next hop self on every single hop. Say it only on router B. And router B will put its own address and send it to C, D, and E routers inside. Next up self. This is the command next up self. Yeah. So after saying next up self, you can see router B is advertising its own address. See, it is not putting its egress interface address. It puts 2222. Why, According to router C, router B is identified as 2222. So the next stop address will be the peering address. It will not be egress interface address. If egress interface address of B is the peering address of C, then it is okay. But when C peers with B with 2222, this next stop self command will put 2222 as the next stop, not the physical interface address. See, on B, when I say next stop self, it is not sending 10.1.1.1 as a next stop. It sends 2.2.2 as a next stop. Why? For router C, B is identified as 2.2.2.2. Likewise, for router B, C is identified as 3.3.3.3. All right. So these are the things that we need to do in our lab environment, and we need to test these things. All right. So one is next up self. The other one is BGP multi-hop. Then update source. We will do it in the next class. Let us finish this chapter by covering another topic called peer group. Peer group or neighbor group, both are same. In iOS XR router, peer group is called as neighbor group. Both are same. Peer group, neighbor group. So let's learn peer group. What is peer group? See the first point in the second section. This command defines the template with a parameter set for a group of neighbor instead of individually. What does it mean? If I have some set of commands to be configured for group of neighbor, then instead of going to each neighbor and giving that set of commands, we can just create a template, put those common commands, common configuration inside the template, and we will call the template with a neighbor. Let me repeat again. Let's say I have 5 CCIE students in a class. Instead of telling 10 points for each student, I'll just say these 10 points is for CCIE participants. I'll give heading as CCIE participant. And I'll put all those 10 points that I want to share with you. And then I will call that template, which has got the 10 points, with all the neighbors. What is the advantage? Advantage is time saved. I no need to repeat the 10 things with the 10 different neighbor. It will become 100 line of configuration. Now when I have a template, I got only 10 line of configuration because I have only 10 neighbor. And the template has got the 10 points in it. Not only that, see, not only the configuration is simplified as the last point says, the previous point is more important for me. Updates are generated once per peer group. So if I want to say 10 different things to 10 members of our CCI batch, when I say the first point, the 10 student will process that first point. After that, when I say the second point, they process the second point. Likewise, they have to process 10 times because I'm giving 10 different points. And then they have to conclude what I am trying to say. Instead, if I put the 10 point in one template and just show it once, boom, look it for yourself. They just do single time processing and decide the policy that I'm trying to configure. So members can have different inbound policy, but where they have a common outbound policy. When there are members with common outbound policy, I may use peer group. See, inbound policy, no need peer group, you see. Inbound policy, there is no peer group needed. Only for outbound. Example, all these neighbors need to form neighborship with that particular remote address. That particular remote. So that's an outbound. Whenever sending an update to those neighbors, we need to source it with loopback 0. That is also outbound. So anything that is outbound and common for many neighbors, we can use this template called peer group. For example, you see here, the one with the left hand side big box is without peer group. See, the box size is big. Same configuration is done using peer group, which is on the right. Same configuration. In fact, the configuration that you did in the right hand side is more effective, less process utilization because it is single time processing for each neighbor. Whereas on the left hand side, for every line of code, there will be a separate process consumed. Same thing you're configuring, but the difference is on the right hand side, you have a template with those 4 common things. You want to configure all the neighbors with the remote AS 65100, you see. All 3 neighbors with this, and all 3 neighbors with the update source loopback 0, all 3 neighbors with the next stop self, all 3 neighbors with some distribution list for out filtering. So I put all of them in one template called internal. That's the name given by you to identify the peer group. It can be any name, okay? And you call that peer group just in one process. All this will be processed. That's a very big advantage. Simplified as well as more effective. For outbound policy, you can configure this peer group. Please ask me question if you have on peer group. Okay, you see, we have we have not gone to attributes. So understanding outbound policy, incoming update, those things may be too early. Now, our aim in this example is to understand that we can create a template and call the template instead of writing it individually. Now, let me try to explain you the outbound policy also now. To an extent, you will understand the depth of it. You will understand when we go attribute. You see, router C. If you see router C, we are not focusing on incoming. We are focusing on outgoing. If an update, if a BGP packet goes out to this address, make sure they belong to this autonomous system. So when BGP packet is generated and sent, in the BGP peer message, in the BGP open messages, you will find this autonomous system number going out to negotiate with router A, B, and D, A, B, and D. With this, not only that, it will also go with the source address as it goes out. As the packet goes out, it picks the loopback interface. Not only that, if there is any update that need to be sent out to this three neighbor, I'm going to say I myself is the next stop. I'm going to put my own address as the next stop. And then when I'm advertising some prefixes to this three neighbor, I follow the distribution list 20. What is distribution list 20 is not explained here. That may have some routes to filter or suppress. So all these things are talking about while we speak to others. These are the things. It's not focusing on while someone speaks to you. It's not saying when A talks to you, you do this. No. It says when you speak to A, when you speak to B, when you speak to D, this is what the remote AS should be. This is what the update source should be. This is what the next stop should be. And these are the prefixes you are supposed to advertise, which is defined under the distribution list. So here the outbound policy is not outbound to the autonomous system. It is outbound to that router. Peer group is per router. One side I may use a peer group, the other side I may use individual configuration, doesn't matter. So outbound policy if you keep autonomous system in your mind and see, then you will not have a clarity here. It's per router. Next is the advertisement. Yes, sir. Most welcome. See, question is, eBGP routers usually distributes the external route to all the inside routers. Do we need to have a policy for the distribution? That is what Sheikh's question is. Let me repeat the question again. Sheikh, if my question is wrong, correct me in Tamil. I'll put your question in English. The question is, router B and C, they take those external routes coming from 65101, the route advertised by 65101. They take the routes and they advertise it to inside routers A and D. When they are supposed to advertise whatever 65101 gives, then what is the policy involved? What is that outbound policy that is involved? What sort of freedom they have to do this? That's what his question is. That they're supposed to give whatever that autonomous system gives. Do they really have any privilege or command over the route distribution? Answer to your question is my question correct, Sheikh Ji? அங்கிருந்து வரதை கொடுக்கறது தானே இவன் வேலை. இவனுக்கு என்னதுக்கு இன்னொரு ஒரு பாலிசி இருக்குது? எதுக்காக இவனுக்கு ஒரு பாலிசி தேவை? அதுதானே உங்க கேள்வி. So that's what I put it in English. So answer to your question is, see, our router, our resource, it's our wish whether to distribute whatever comes in same without any alteration or with alteration. It's our desire, it's our wish, our policy. 65101 is not our autonomous system. When it is not our autonomous system, whatever they give us, not necessary for us to just distribute blindly. We can have our own policy saying, this is what I will distribute to my inside router. Other things I will filter out, I'll suppress it. So in single line, answer to your question is, we can have our own policy. We need not to simply handle all those updates same as it is sent. We can alter. We are allowed to do it. புரிஞ்சுதா? Did you understand? நமக்கு சுதந்திரம் உண்டு. நம்ம இஷ்டம்தான். அவன் கொடுக்கறது எல்லாத்தையும் அப்படியே அனுப்புறதா இல்லை அதில் கொஞ்சம் ஆல்ட்ரேஷன் பண்ணி அனுப்புறதாங்கிறது தீர்மானிக்கிறது நம்ம தான். ஏன்னா நம்பர் அவுட்டர், சியும் பியும் நம்பர் அவுட்டர், ஏவும் நம்பர் அவுட்டர் தான். It's our autonomous system, A, D, B and C. So we have full rights to decide what to advertise to our inside router, what not to. Sheikh Ji. Right. So the next is the network command. See, BGP is the protocol with very strict behavior, meaning it's like a Very disciplined watchman, very disciplined servant. BGP is a well disciplined servant. Whatever you say, only the servant will follow. The servant is not like EIGRP. The servant is not like OSPF. What do I mean by that? See, I have OSPF running on this router and I got 10.1.0.0/16, 10.2.0.0/16, 10.3.0.0/16. If I'm running OSPF and when I say network 10.0.0.0, wildcard mask 0.255.255.255, area 0. When I do this, OSPF will now run on all three interfaces. One of you have not muted your mic, please mute. So OSPF will start running on all three interfaces. Even though you have said /8, is it not /8? Of course it is /8. I have mentioned /8, but are they really /8? No, they are /16. So will there be a /8 in the routing table? No. There won't be root with /8. But still, OSPF will run on all these three interfaces because they all simply begin with 10. Because they begin with 10, OSPF will run on all three interfaces. Same way EIGRP will also run on all these three interfaces. If you don't mention, assume this is EIGRP. If you don't mention the wildcard mask, if you simply say 10.0.0.0, it is going to run on all three interfaces because all three has got 10. But BGP is very strict to discipline the protocol, meaning you need to exactly match with the mask on the routing table. In BGP, when I have these interfaces and these IP address, when I have /16, the routing table will not have /8. So if I simply say network 10.0.0.0, BGP will not be running for any of this network. BGP, if you don't say mask, if you say simply network 10.0.0.0, it will assume like /8 and check for /8 in the routing table. Do we have /8 in the routing table? No. For 10 network, we have only 16. So your configuration is accepted, but no action taken. Your configuration will be accepted, no errors thrown, no error message, but no action taken. BGP won't be running on any of, won't be advertising any of this network. We need to put the mask command. And mask command, we need to put the mask command and match exactly to the mask that is seen in the local routing table. Only when there is a match, the route will be announced. Otherwise, no. If you don't use the mask, it means class full. For that also, match should be seen in the routing table. If not advertised. Again, in all other protocols, the network command will enable the routing protocol in OSPF, in EIGRP. But here, network command will not enable BGP on that interface. This network command will be used only to advertise. It is the neighbor command using which we form neighbor. So do not forget the mask that we configure under BGP should match. The mask that we configure under the BGP network statement should match with the mask that is there on the routing table. If no match found in the prefix length, if no match found in the prefix length in the routing table, the router will not be advertised. Please ask me question. No questions? Yes. Yes. See, you can put it in Tamil, not a problem. நீங்க ரவுட்டிங் டேபிள்ல ஒரு நெட்வொர்க்குக்கு என்ன மாஸ்க் அந்த நெட்வொர்க் கொடுக்கப்பட்டிருக்கோ அந்த மாஸ்கை ஸ்பெசிஃபை பண்ணணும். அது கிளாஸ் லெஸ்ஸாக இருந்ததுன்னா, ரவுட்டிங் டேபிளில் கிளாஸ் லெஸ்ஸாக இருந்ததுன்னா நீங்கள் இங்கே மாஸ்க்குன்னு ஒரு கீவேர்டை போட்டு, இந்த மாதிரி மாஸ்க்குன்னு ஒரு கீவேர்டை போட்டு பாருங்க. இங்கே ரவுட்டிங் டேபிளில் இந்த ரவுட்டிங் டேபிள் தே ஹவ் சம்மரைஸ்ட் டு /16. We all know 192 is /24. 192 means class C. We know it is /24, but in routing table they have a summarized route. So if you wish to advertise that summarized route, you have to match exactly the mask. If it is class full, you no need to mention this mask. If you mention nothing wrong, you no need to mention also. So we have to match with the mask that is there in the routing table if you expect the BGP protocol to advertise. When we do the lab, you will understand better. If you didn't understand now, you ask question. I'll try to explain. If not, you will understand when I do the lab. Very correct. It will be seen only as a neighbor. It won't be seen as the BGP advertised network. Yeah, it is there in the global routing table because we might have written a static route or IGP protocol so that BGP can have a reachability to negotiate. But as you said, BGP's routing table, BGP's forwarding table will not have that neighbor address. It will be only seen in the neighbor table. Exactly. Very clearly said. Yes. Very clearly said. You have very clearly explained. So the routing table should be matched. If someone says the interface subnet mask should match, they are half correct. There are chances that I might have summarized it. So now I don't need to match with the interface. I need to simply match with the routing table summary route. That is enough. So saying routing table is more appropriate than saying match with the subnet mask on the interface. That is not actually the right explanation. So here they are giving you a nice example how much the mask and the mask that you specify here and the mask that is there in the routing table are related. We have a static route pointing towards a null interface like this: IP route 192.168.0.0, 255.255.0.0, null 0. This is the static route we have written. In general, 192.168 is /24. Because you wrote static route like this, it is /16 in the routing table. Because there is a route match in the routing table, now I can advertise this. BGP will advertise /16 for 192. Otherwise, it's not possible, 192.168, how can it be 16? Unless you do something like manual summarization or static route pointing towards null 0. Something have to be done by us so that /16 will be there in the routing table for this network so that BGP can boldly advertise it. No problem. Yes, that is right. Yeah, for directly connected, in some iOS versions, not in all iOS versions, you will have L and C. L is over the link, what is the IP address and what is the mask, and what is the summary of that link address. But it won't consider that summary address. It will consider only the link mask, links mask. That's not in all iOS. After 15 dot versions have got this in what you're saying is not seen in 12.4, which is very famous. After 15, we started seeing in the routing table both C as well as L. L is the exact mask and C is the summary of it. L specific, correct. Maximum prefix length is what going to be seen for the packet. All right. So next is about BGP synchronization rule. This is actually off. Earlier it was there on, but after 12.280 and later version, meaning none of the routers today has got this issue. Before this 12.2, we need to put this command every time you configure BGP. Every time you configure BGP, you need to put this command because it was a headache. What is that headache? What does it mean, synchronization? See, the word says synchronize. Synchronize with whom? BGP synchronizing with IGP. That is what this rule is about. BGP have to synchronize with IGP. Yep. So why should the routes of BGP need to be seen in IGP? Useless rule. Why should external routes that BGP brings in need to be advertised in OSPF? You remember, we even try not to redistribute when we had that full mesh problem. We were seeing that redistribution itself is not recommended. Now, this rule says if you need to advertise any external route that you learned, make sure that route is well known to IGP. Only then you can advertise. Who will accept it? No one will accept it. We just bring this into a practical day-to-day life scenario. No one will accept it. Let's say onion. Onion is an eatable, it's a vegetable. Some poor guy from India carrying onion to, let's say, America. In the transit, he is in a screening in one airport. He himself don't know about that country. In that country, onion is banned. Assume. According to this country's rule, you are under arrest because you are carrying onion. How cheap it will be. He is in transit. He's starting from India going to US. Some country in the middle, the flight got landed for connection. And if that transit airport says in our land, according to our rules and regulations, you are not supposed to carry onion. You need to carry only those things are synced with us. This is funny actually. You should carry only those things that are allowed in our country. The middle is neither source nor destination. It is just a transit. Now let's read this line, 3 line. Do not use or advertise an external neighbor, a route that you learned by IBGP, until a match route has been learned from an IGP. This was one useless rule, so they used to turn it off by putting no synchronization always. But now good news is it is already no synchronization. See, this is what that synchronization rules say. This network, this network. A cannot use it, A cannot advertise it until OSPF talks about this network. Why will OSPF talk about that network coming from outside? OSPF is the protocol of inside. So after the synchronization rule is off now, which is default by off, E can send, but earlier E cannot send. E cannot hear the route, so E cannot reach the route. E cannot send anything. But now E can hear the route, it can send the packets now. Please ask me a question, but this is not a topic to be discussed because it is no more a problem. I'm just telling because you might have come across this in an interview, or you may be facing an interview in future. You may come across most of the interviews, especially interviews conducted by our country people, wherever they are, they never change. They ask this type of question only because people don't focus on these silly things and they want to know only those silly things in the interview. What to do? So for that, I have explained this. Any question? Let's. Sheikh are you flying in a helicopter? Private jet? No, your voice is not good. Sheikh, that's all, this chapter is, we have to do the configuration and then I think we need to come back to this chapter again because BGP states we have to, first let us finish the configuration part. So far we have learned like next hop self, eBGP multi-hop, update source loopback 0, and then IBGP peer group. Not only for IBGP, you can also use for eBGP if it is necessary, but mostly we'll use only for IBGP. So let us do all these topics first. So tomorrow and the following day is going to be the lab day.